Central limit theorem. Central limit theorem is an important concept in statistics. Central means key or main here. It was presented by Laplace. He was a French mathematician and astronomer. Suppose we have a random variable x and it has a distribution which may or may not be normal with mean mu and standard deviation sigma. Samples all of the same size n are randomly selected from the population of x values, and then means of these samples are plotted in a distribution called as distribution of sample means or sampling distribution of the means. Suppose here we have some 200 digits from social security numbers. Social security numbers are like your ID cards, national ID card numbers here in Pakistan. In America they have social security cards. Suppose we have a population and this population is made up of these 200 digits, and what we do over here is we take the frequency of each of these digits. This SSN may be any digit between 0 to 9. So we take the frequency of these digits, how many zeros are here, how many ones are here, and then we plot it into this diagram that looks like a frequency histogram. But if you look into the shape of this distribution, in fact this distribution is a population, it does not seem much to be normal. What we do next is we take samples from this distribution or this population, and rather than plotting those individual samples, suppose we have our sample size equal to 4 and we have 50 samples, and rather than plotting the individual numbers, we take their means of each samples and plot those means into this distribution, and this is the sampling distribution of the means. Now we look into the distribution of the means. That shape looks like normal. Same way, what is the effect of the sample size? As we increase n is sample size, the shape of the distribution becomes more close to a normal distribution. So here in this simulation, we are looking into the effect of this sample size. So we take sample sizes 1, 2, 4, 8, 16, and 32. And we see here that as we increase the sample size, the shape of the distribution becomes more normal. The key points for this central limit theorem: number one, the distribution of sample means x bars, sometimes we can say y bars, x, y, whatever letters we can use. We call this as sampling distribution of the means, will approach a normal distribution as the sample size increases. The mean of the sampling distribution of the means is best estimate of the population mean. That is, I would say mean of the means is mean. Mean of the means is mean. So this mean that is coming from the sampling distribution is a good estimate for the population mean. The standard deviation of this sampling distribution of the means can be estimated by sigma divided by square root of n. This thing is commonly known as standard error or standard error of the mean. Some rules commonly used: sample of size n larger than 30, the distribution of sample means can be approximated reasonably well by a normal distribution or z distribution. The approximation gets better as the sample size becomes larger. If the original population is itself normally distributed, then the sample means will be normally distributed for any sample size n, not just the values of n larger than 30.